You can send an email. Yeah.
But maybe big file.
Yeah. If the file is too big, maybe you can send through my email. So today you just can share the screen and going for the class. Okay, the time is come, Professor E. Thank you very much, student. Very good afternoon. Welcome to Fisheries Oceanography class for the Fisheries Resources Utilization Study Program. And today is the first class from Professor E. She is a professor and actually a vice president in National Taiwan Ocean University from Taiwan. And we are happy for having you today, Professor. So, like I have described yesterday when we did our opening ceremony, you will have a class in Fisheries Oceanography, maybe for more than 100 students. But today is for the first class, maybe we will have 40 students, 30 to 40 students. So around 1 hour from 1:10 until 2:10. Please, Professor, you can start your presentation about fisheries oceanography. And student, please feel free if you have something to ask to Professor. So we will have maybe 50 minutes for Professor E to present the material today. And then maybe we will have 5 until 7 minutes for discussion. So student, please prepare for the discussion section. Please, Professor, you can start the lecture.
Okay, good afternoon. Did you see the PowerPoint?
Yes,
in the
yes.
screen? Okay,
yeah,
thank
the
you.
PowerPoint is clear.
Okay, so and thank you. It's my pleasure to how to say share my experience about the fishery oceanography. And I am Ming Andy, and professor at the National Taiwan Ocean University. So, where is the National Taiwan Ocean University? Is located at the north tip of Taiwan. Its location is around 121 degrees east and 25 north. And the right later is the university view from the university to see the ocean. And in the outside of the ocean, we can see there have the, how to say, the coastal fishery. They try to use the light to attract the marine life and try to catch them. So this lectures, we hope to let you know if you go to the coastal area, maybe you can see the many activities like this slide. From this slide, you can see maybe in the coastal waters have some pollution, maybe conduct from the agriculture or the factory. In the right panel is an example in the Floridas in the Atlantic Ocean. This is a well-known dead zone due to a lot of the high nutrients from the like agriculture. So the high nutrient drain into the ocean, sometimes maybe impact to the ocean, and then the high pollution will be induced like the red tide. This is the kind of red tide. And in the coastal oceans, sometimes we can see the other activities like the coastal fishery, ocean fisheries, or the traditional fisheries. So this course, we hope to know the marine life, they stay in the ocean and its relation to the fishery. And for the oceanography, it is interdisciplinary science. If we like to see the marine life in the ocean, in general, we can from the different aspect, maybe like this slide show the physical, chemical, geological, ecological, and meteorological aspect. But for the fishery oceanography, we hope to know the mechanism like the aggregation and the disappearance of marine life associated with the environment in the ocean. So we can summarize the and focus some key environment like the physical, chemical, and the biological environment. And the marine life, they generally like to stay in the ocean. We can try to divide the different zonation for different marine life. In general, so we can have two kind of the methodologies to divide the marine life zonation. One is based on the depth or the distance away from the coast. So from the left panel, if we distribute the zonation based on the depth, we can find here have some different zonation like the epipelagic zone, mesopelagic zone, mesopelagic zone, like that. And the right panel shows we can divide the different zonation by light. So maybe we can divide it three zonation like the photic zone and the tree-dyed zone and the photic zone. So different marine life, they will have a different zonation. Like this figure, this is an example for the epipelagic zone between surface and 200 meter. In this zonation, we can based on the downwelling light intensity. So it's functionally similar to the euphotic zone, and nearly these areas, all photosynthesis marine organisms live in this zone. And in this zonation, all epipelagic organisms adapt to well-light environment with few horizontal obstructions. So in this area, we can see a lot of necton and planktons. For necton, this is a pelagic organism that can swim freely. For the plankton, it will be drift or the swim very weak or unable to move against a current. So this is, we can see the ocean is not just one habitat, like the epipelagic zone, mesopelagic zone, like that. So here is some example of the ocean habitat. For example, we can call the open ocean. This zonation is far away the coast, maybe based on the its depth is 200 meters. And we also can see the rock shore or the coral reef zone in the coastal area. So here is maybe you can try to match the different marine life to match the ocean habitat. For example, here is maybe have a rock shore, muddy shores, open ocean, kelp forest, coral reef, seagrass, and the deep ocean. So maybe you can try to find a which kind of marine life they will be match up the left side of the habitat. For example, tuna, it should be the next day in the open ocean. So this slide is try to give you the answer. In the open ocean, the tuna, they like to stay in the open ocean zonation. So we can understand the different zonation. They maybe have the different marine life or the communities. So it means they have different environmental factors will be affecting marine life. This slide shows the marine life may be related to the biotic environment or biotic aquatic environment. For the biotic environment, we can also divide two parts. One is major factors between the two members of the same species. For example, there are some factors like the state of the nourishment, fat contents, like that. Or another kind of factors is between two different species, like the competition or the like the precipitation, like that. Another kind of environment is a biotic environment. We can summarize as the physical and the chemical environment. For the biotic environment, here is the example key issue is predation, like the food chain. Each food chain is represent the flow of the food energy from one feeding group of organism to another. In general, we have two types of food chain. For fisheries oceanography, we will focus on the gradient food chain. So what is the significance of food chain? The food chain knowledge will help us to understand the feeding relations as well as the interaction between organism and the ecosystem. It also helps us to understand the mechanism of energy flow and the circulation of matter in ecosystem. Also helps to under the movement of toxic substance and the problems associated with the biological modifications in the ecosystem. So this slide shows the food web or food chain structure. In general, the food web can be defined as the network of food chains, which are interconnect at the various trophical levels so as to form a number of feeding connections among different organisms of a biotic community. This slide shows the three levels food chain of herring or food web of northeast herring. So this is two kinds of food webs structure. One is food web, one is food chain. For the three-level food chain of herring, we can see here is just only three level. One is diatom, second is the Canis copipodas, and the predator will be the Newfoundland herring. Our right side the food web for northeast herring, it will be contains many food chains. So it will be complicated. So food chain or food web will be have that as to study the bottom-up or top-down control of the community structure. This slide shows the food bottom-up control. This slide is bottom-up control. Here have the 4 levels, the trophical level, food chains, the structure. This is the typical the bottom-up controls food chain. It will be the production and the abundance of population is controlled by the production and the abundance of population in the traffic levels below them. So here we can see the vertical zone. There's abundance related to time. It is negative relations. So we will respond to the zooplankton. Its relation is also negative between the abundance and the time. So forage and the predator is also controlled by the production by the zooplankton and the phytoplankton. So this is a bottom-up control. So we'll be from the low traffic level, transfer the food energy to the high traffic level. Next is top-down control. This control mechanism it generates accuracy when the population density of a consumer can control that of its resources. Under this top-down controls, the abundance or biomass of low traffic levels depend on effects from consumers at high traffic levels. So here we can see the predator, the relation between abundance and the time is negative, but it will be control the forage fish relation will be transferred to the positive. It means the predators high abundance will be eat more the forage fish. Therefore, the forage fish will be decrease their abundance. So under the top-down controls, the traffic level relation will be similar to the zigzag relation. Except for the biotic environment or the biotic environment. Here we try to say something related to the climate change or the human impact. Here is one example if like the climate change impact to the forage fish. In general, this kind of the food chain mechanism we call the waste control. It will be combined the bottom up and the top down. When the environment change or the climate change affect the forage fish, we can see the forage higher than the forage fish, the traffic level will be a kind of a bottom up controls the food chain structure. However, below the food forage fish traffic level, the food chain structure will be changed to the top down. So waste control is a kind of the food chain structure possibly influenced by the environment or the climate change. Sometimes the environment change or climate change also will be a kind of spatial bottom-up controls. It is a typical or the specific case when the environmental influence for the phytoplankton. When the climate change impact to the phytoplankton, that the photoplankton increase or decrease will be impact to the for the ecosystem or the for the food chain. This example is reported by the Professor Kamura in 1983. He tried to give an idea for region shift. This is a typical region shift idea for sardine versus and the anchovy region. Region shift is a kind of a decadal variation, for example, 20 to 30 years climate regions. This case is try to show the climate region for cold or warm region. It will be appear to favor either anchovies or sardines. So what's happened when climate region? This slide shows the environment change. For example, physical forcing. When wind, light, temperature, and the current changed. In the right side is the water current is stable. It means in the Pelagic ocean will be warm and stratified condition. In this condition will be the less the nutrients the condition. So the photoplankton is not easy to absorb the nutrient. Their growth will be slow, so their size will be small and small biomass. Therefore, they are difficult to transfer the energy to the high traffic, such as the Copepoda. So Copepoda will be size small. In this condition, will be favored to the sardine, because sardine is a kind of a non-selective species. And another condition is water current mixed in the left side. This condition is kind of a strong upwelling. Upwelling condition will be induce the cold water from the deep sea to the surface water. So it means will be accompanying the high nutrients from the deep sea to surface. Therefore, in the surface water, the photoplankton will be easy to absorption the nutrient and absorb the solar energy, try to do the photosynthesis, and easy that the photoplankton to grow. So in this condition, the photoplankton will be easy growth and the size is large with the large biomass. Therefore, it will be easy to let the Copepoda to eat and growth. So Copepoda will be also grows up. In this condition, will be favored to the anchovy. This kind of species for size selective particle feeding. So in the environment, so in these conditions, sardines and anchovy will be due to the warm region or the cold region. There will be a decadal variation. So this is the Professor Kawamura, and he provided this idea in 1983. So we can easy to understand the marine life state. We can easily understand the marine life in the ocean, and in the ocean we can see here is different zonation. So maybe have a different kind of fishery. For example, traditional fishery, coastal, or the oceanic fishery. So how about the fishery? Fishery have several functions, like the eat for the subsistence due to the marine life. Maybe they can contain the many high health is for children or women. It will be healthy for the people. So it's a good function for eating. Another is maybe for sale is important issues for commercial. In right side is a trend in the global fish production since 1950. So from this figure, we can see the marine fisheries production is increased since 1950. However, in the different countries, they have the different production. Right lower panel shows the top 10 countries with the top high catch. Number one is China, second is Peru, and India, and Indonesia. So fishery is important for some countries to their population. The third function is maybe like the recreational. Right panel shows the recreational fishery in Taiwan. And people, they can chicken in the coastline or the recreational fishing boat. They can easy to or the relax their marine their life. Try to the fishing. So this is the third function for fishery. So where is the fisheries place? We can call it is the fishing ground. Fishing ground, maybe we can try to say it is a water area where the aquatic organism, maybe like tuna, yellowtail, mackerel, something like. Often fisheries, they are swimming over over and try to up there, and the fishery they are can commercialize. I think is the important issues in the fishery ocean grade. This is examples fishing ground. sometimes we can call the habitat of marine life. This is an example for the spawning ground of alpaca or the feeding ground in the wall. Up panel shows the spawning ground, and when the water temperature, sea surface temperature, rather than 24, we can see the alpaca like to stay at near to the plus or minus the 20 degrees latitude area. However, for the feeding ground, the sea surface temperature will be less than 24. They like to stay in around the area higher than the maybe 30 degree latitude in the south or north. So the feeding ground in the habitat will be different depending on the their behavior. So the fishery ocean ground, Hartjord, he tried to say it is a kind of acknowledgement, try to know the renewal of the fish stock must depend upon highly variable nature conditions. So sometimes they try to analyze the irregular number of young herring and the codfish and give this the definition suggestion. So like the left corner, when the environment will change, the phytoplankton will be abundance of biomass will be changed, and will be respond to or the control the zooplankton biomass, and also respond to the forage and the predators abundance of biomass. So what is it? This the fishery oceanography. From this figure up panel, we can see that in the different area or the habitat, we can find that they are different feeding ground, like the tuna, squid. So if I try to find tuna stay here, squid stay here, so we can say fishery oceanography is a kind of applied branch of oceanography. And 1961, Worcester, he tried also to explain fishery ocean ground is kind of a study of oceanic process affecting the abundance and availability of commercial fishes. So it will be integrated oceanographic for the and oceanography and the behavior of fish with the fishing technology. So this is the we can say what is the fishery oceanography. So like this slide shows the spawning ground of alpaca and the feeding ground alpaca. They have different the sea surface temperatures, the habitat. We based on this idea try to do the habitat model like this slide published in the remote century. And we can see there's the optimized environment like the sea surface temperature and the chlorophyll concentrations. There's the optimal relation show this slide. So fisheries oceanography in context will be include fisheries, fishing, management, and the policy, and the oceanographic and the climate change. So maybe some questions in fisheries. We hope to know the where to live for each stage of marine life, or which kind of food to eat and how to obtain it, how to avoid predate, and where, how, and when to produce. So summary is this definition is this deals with description of marine commercial communities and the interaction between physical, chemical, and the biological properties that determine the nature of this association. After this, maybe next step is ecosystem oceanographic. This is led you to further thinking. Okay, this is today's the introduction for fishery oceanography. So, any questions?
Thank you very much,
Thanks for your
Professor.
listening. Okay.
Yeah, thank you very much, Professor. If you don't mind, maybe you can send this slide or this file to my email, so I can share to the students to more understand about the introduction of fisheries oceanography. Thank you very much, Prof. E.
No problem.
Student, is there any question? Please, if you have anything to ask to Professor, please feel free. You can directly say something. You can directly ask to the professor, or you can just send the question in chat room. Okay, one student, Mr. Muhammad Zikri. Zikri, please. Zikri, please.
Thank you, sir. My name is Zikri. I want to ask about pollution. What type of the pollution in the Taiwan's water, and how is the Taiwanese government trying to solve the pollution problem there?
Okay, thank you for your question. So you mean the pollution? Pollution is right?
Yes, sir.
Actually, in the waters around of Taiwan, it is almost no pollution. Due to Taiwan have how to excellent environment, like the crucial. Crucial is a kind of a strong current from the south to north. So when the some maybe pollution produced by the factory from the river to the ocean, it is easy to how to say is live by the current away from the Taiwan. So almost no pollution in the waters around the Taiwan. It's my answer. Thank you.
Thank you very much. Zikri, clear? Yeah.
Yes, sir. Thank you.
Yeah. Another student, please.
Excuse me, Mr. Abu.
Oh, yeah.
Let me
Okay.
ask a question for
Okay.
Professor
Yes.
Lee.
Thank you.
So between the coastal area and the open ocean on or high seas. So my question is, which one area is more productive for fisheries? I mean, it has abundance of fisheries, and why make it productive? Thank you.
It means that maybe where is the good fishing ground. In general, is the how to say is the where is the food produced? Like the in general, is we can say the upwind area is the most productivity zone. Due to this area will be a huge nutrients maybe supplied from the deep waters. So this area in general is the high production area. So it will be a good fishing ground, or fish like to stay there for feeding. Another possibility area maybe somewhere from the area, because this area will be the also have the high nutrients will be aggregation in this area due to maybe the physical or the biological features. For example, the tuna, maybe they like to stay in the open ocean, but they did not like to stay in the coastal area due to this area may be related to the cold water. So they maybe like to stay in the coastal and the oceanic the boundary area. We maybe call the summer from the area, profile from the area, like that. So if we can use the some technology to detect the upwelling or the summer from the area, we can maybe easy to find the fishing ground. It will be help to let the fishermen to easy to move or save their coast, something like that. I hope my answer you can easy to understand.
How, Novel?
Yeah, I think enough. Thank
Yes.
you, Professor Lee.
Okay, thank you.
Thank you very much, Novel. Is there any other question, student? Please feel free. We still have enough time. Okay, student. Okay, Professor. There
Yes.
is one. There is one question. The student sent to me. The question is, how can we identify marine fish as selective or non-selective filter feeder?
Okay. So a selective or non-selective feeding is depend on the how to say the sardine or anchovy due to their mouth size. Your mouth, because its mouth is small or large, due to in the waters, the sardine or anchovy, they like to eat small size or large size, because anchovy, they have a big mouth than sardine. So for anchovy, they can only to choose large, because for them, they can save energy to eat. For example, if you eat the rice, if you eat one by one or 1 month, for anchovy, they can eat 1 month. But for sardine, they just only small size months, so they cannot to eat the large. So just only for small size zooplankton or copepoda. Depending on the fish, their mouth size.
Okay, thank you, Professor. Is there any other question or comment? You can directly ask to the professor or send the question in chat room. Oh, there is one. Okay, I will read this question again, Professor. The question is, the interaction of all oceanographic parameters can be used in predicting fish habitat. What is the most important oceanographic parameter in this case? Physical or chemistry? Or if physical, which parameters? Thank you, student.
Okay, actually, this is complicated questions, because it's depend on the different kind of species. Some species, maybe they and sometimes maybe you can consider it's the stage for their growth, for young, junior, or adult. Maybe they have a different behavior or the feeding, how to say, they like to eat. Sometimes maybe their prey, they need to meet them. So if the how to say, the zooplankton or their prey, they have the match up or mismatch up. Like today, we meet together on website, so we meet each other. But tomorrow we cannot meet, so I am your prey, you cannot eat me. So it will be random the conditions, and depend on the different species and there's the stage of the growth up. So it's hard to say which parameter is important. For examples, some species like in Taiwan, we have one kind of a species in the November 4. I will be show the spawning ground and spawning migration of a moon crab. It is kind of a migration species in winter time. this species will be follow the 20 degrees Celsius water. So if a fisherman can easy to detect the environment for 20 degrees Celsius, maybe we are easy to find the gray mullet. So it will be depend on what's the condition of a fish. So it's hard to say the which parameter is most important. In general, physical factor, temperature is important. For biological parameter, food availability is important. So where is your prey? Density will be affect the fish abundance. Sometimes it will be the integrated difference.
Thank you.
Okay.
Thank you very much, Professor. We also have Dr. Bambang Semedi here. Good afternoon, Pak Bambang. You are on the way. Be careful.
Okay. I'm sorry.
Yeah, thank you. Yeah, please, Dr. Bambang.
Okay, thank you, Pak Abu. Yeah. Hello, everybody. Ni hao ma,
How?
Professor Lee. Sini. My question is not complicated. I have one question. Yeah, do you remember mahi-mahi, species mahi-mahi? You
Yes.
have in Taiwan. Also, we
Yes.
have in Indonesia.
Yes.
So, but the habitat, of course, a little bit different.
Yeah,
So
yeah.
I'm not sure that's kind of a species is the same species with between Indonesia and Taiwan water species. So it is just give a suggestion. Please make a kind of research for near future. Yeah. So
Okay.
you can compare between Taiwan mahi-mahi and Indonesian mahi-mahi. We have a lot of in the coastal area nearby Malang. Yeah. Okay. So we invite you to come to Indonesia and please make a collaboration research with our faculty here. Okay. Just suggestion. Thank you very much. 谢谢你.
Okay, thank you. Your question or suggestion actually is we are glad to cooperate together. Yeah.
Yeah.
Maybe in future due to COVID-19 issues, we hope that we can quickly to do just the cooperations discussion. Yeah.
Yes. Yes.
Thank
Okay.
you. Yeah.
Thank you. Thank you very much, Dr. Bambang. Thank you for joining us
Thank you.
today. And I believe both of you will be an invited speaker for the UB International Conference. Dr. Bambang and also Prof. Lee will be one of invited speakers in the conference. And also, especially for Professor Lee, you will be in the next day, maybe November 4th, you will also be our invited speaker. So in 1 month, you will be, you will have two kind of international symposium in Dawijaya University. So thank you very much for receiving and accepting our invitation, Professor. I believe you are very busy. You are now as a vice president in National Taiwan Ocean University, but we are lucky for having you today, and we are lucky for having you in this 3-in-1 program. You can share all of your knowledge, your experience, your expertise in fisheries oceanography today, and also the class after today. So thank you very much, student. If you have any question, we still have maybe 1 minute. We are so lucky student. Teman-teman mahasiswa, beliau ini adalah Vice President, jadi setingkat wakil rektor. So he is very busy, so we are so lucky for having Professor Lee today, and also for the next class, and also for our faculty's international conference. Professor Lee, maybe I think this is the last question from the student that sent to me. Oh, okay. Bu Aida. Okay, we have a Dr. Aida here, one of our senior lecturer here. So please, Dr. Aida.
Yeah, thank you very much, Mr. Abu, for inviting us to have a question. Good afternoon, Professor Lee. My name is Dasar Timbul. Nice to meet you here. Yeah, maybe similar with Professor Bambang. We will happy if you have a collaboration with us. Yes, I have one question.
Yes.
What do you think about the implication of climate change and fish migration issues? Since there is based on eDNA information, there is some Taiwan sardine migrate to Indonesian area, and also we lack of Sardinella lemuru too in Indonesia, in some part of Indonesia, especially Sardinella lemuru is originally in Bali Strait, but now it has become very, very low catch. So what do you think about that? Is it possible to have a collaboration, or maybe what do you think about the migration issues with in relation to climate change? Thank you.
Okay, this is the big issues for the climate change. Actually, each species they have a different response to the climate change. But for anchovy or the sardine is a kind of a species sensitivity to the climate change. In Taiwan, we also have a similar condition, like you say. In Taiwan, we have anchovies, rabies, the fishery, but due to the global warming, the temperature is increased, so the abundance will be decreased. So we also try to do some fishery management for like the total allowable catch (TAC), or the closure the period or the ground. So maybe we can do some limitation for fishing season or fishing area like that. And we also hope to reduce the fishery scale size. So we have to do some limitation for the fishing boat. They cannot use the huge fishing boat to do this fishery like that.
Yeah.
For the cooperation, I think it's possible here.
Yeah.
Okay.
Thank you very much, Professor Lee.
Yes.
Thank you very much. Thank you very much, Dr. Aida. So Professor Lee, actually the teaching coordinator for this course is Dr. Aida. So Dr. Aida is she's the coordinator of our courses. Thank you for joining us, Dr. Aida. I think this is the end of our class today, Professor Lee. So I thank you very much for having you today. In class, we have more than 60 students here.
Okay,
We
good.
have more than 60 students.
Yeah.
Very good and very interesting topics today. So for the next class, maybe we will start again for the topics of application of fisheries oceanography on 21st of October, Professor?
21.
21 of October. Yeah, so see you on 21 of October, student, Dr. Aida, Dr. Bambang, and all staff member here, all lecturers of UB here. See you on 21 October. Thank you very much, Professor E. Have a good day. Keep healthy, Professor.
Okay. Bye-bye.
See you, student.
Okay, thank
Pak
you.
Bambang.
Thank you.
Take care, Pak Bambang. You are on the way.
What did you say?
Bye.
Goodbye.
Bye-bye.
Bye.
Bye. Oke, sampai nanti ya. Jam 15.15.
Iya, Pak. Siap.
Oke, sip. Thank you.
Udah. Jangan ada Bu Aida. Halo Bu Aida.
Oh, tinggal kalian saja ya.
Iya, Pak. Izin untuk screenshot Bu buat logbook.
Kenapa?
Screenshot buat laporan logbook Bu. Ayo.
Sudah? Salib ya?
Iya, Bu.
Oke, Bu.
Terima kasih, Bu.
Terima kasih.
Ayo.
Assalamualaikum.
Waalaikumsalam. Iya.